Okay, theory of consumer choice, ordinal approach. First of all, the one that I asked you to watch the video, it's cardinal approach, it's the old approach. The one that we're going to discuss in the class now, it's a new approach, ordinal approach. Ordinal come from ordering, make the order จัดลำดับ ordinal. Cardinal approach is our approach cardinal. This approach assumes that we have a device called utilometer, like a thermometer. And then when you consume, let's say, eat food or do some activities, you can use this electronic device to measure level of your happiness. Like you measure the temperature, Fahrenheit or Celsius. And the unit of measurements, it's joules. Sound very funny. Yeah. But that's the old approach. Start with assuming this thing. Yeah. You will watch from the video this approach. Yeah. The new approach attack the old approach. That, hey, Mr. Jeremy Bentham, this is the pioneer, the founding father of this school of thought, yeah, cardinal approach. His name is Jeremy Bentham. Okay, let's see his picture now. This is his picture. This guy. Hey, these two person here, new approach, attack Jeremy Bentham. Jeremy Bentham, you make a very ridiculous assumption. How could people tell you about this? They could not tell you how many joules they receive when they drink or they consume or they do some activities. Impossible. You don't have that utilometer. It's in your dream. Then the ordinal approach by these two leading economists, one Russian, the other British, said that we don't need to make this ridiculous assumption and we still can study consumer choice. Yeah. Okay. Ordinal approach, no need, said the response. Okay. So I said, no need to make a ridiculous assumption like this. It's but the two economists that you see their pictures, it is required only that consumer can rank, can order, can say that, oh, I love this at the first rank, second rank, third rank. consumer can rank their preference. Okay. So the story begins from here. Yeah. When a consumer can rank their choice. If you give them two baskets, oh, I love basket A more than basket B, or I love B more than A, or A and B are equally the same. Okay. Yeah. Next. I'm going to bring you to the three rooms in the museum. 1, 2, and 3. The first room is about this question: what does a consumer want? Preference, about preference, รสนิยม preference. Tool that we use to describe preference or taste, we called indifferent curve. Indifferent curve in Thai language เส้นความพอใจเท่ากัน indifferent curve. Regard this as tool, เครื่องมือ to understand people's preference. That's the first room dealing with this question: what does the consumer want? Yeah, when a person visit a car showroom, these people want to buy cars, new cars, and when people buy cars, there are many attributes for the car: acceleration, interior design, this and that. Yeah, we want to understand your prospective customers' preference. Who put more weight on which aspect? Who put more weight for the other aspect? Yeah. Okay. Female consumers, male consumer may have different aspect about the cars. Okay. In different curves. Second room, money talk. Talk about affordability. We use a tool. It's called budget line. BL. Budget lines will help us to identify, okay, there are million baskets in front of you. Some basket you cannot buy. Your money is not allowed to buy. Some basket in front of you, you can buy and have some money left. Some basket you can buy and you finish up your money. Budget line will tell us about these categories. Can, cannot, can, money spent up, has leftover money, explained by this line. And the room number 3, given the preference, given affordability, how a rational consumer choose his best. Yeah. We bring IC and budget line together to understand him. IC and BL together. Okay. So you can see from these trackers, introduction, indifferent curve, the first room, budget line, the second room, and consumer equilibrium, the third room. Now, indifferent curved. We have a checklist that we required the guy that we want to observe his behavior to fulfill, to make sure that we are not talking with insane people. Make sure first that this guy is normal. This guy is rational man, not insane. Yeah. Okay. First, this guy must be able to rank his taste or his preference. So I will elaborate more about this first requirement. Yeah, this is number one. Okay. In between two basket of goods. Yeah. You think of the basket during the New Year. Yeah, people give the basket of things in the basket. Yeah. Basket A and basket B. This guy must be able to give us one of the three following possibilities. Ask him to choose basket A and basket B. Similar to your decision before you come here, you may already got the seat at BBA Chulalongkorn. Yeah? You are choosing between the two choices. So three possibility. Number one, basket A is preferred to basket B for him. He may feel like this. He loves to have A rather than B. That's the first possibility. Or this guy may say, give me B, I want to have B. Or B is preferred to A. Second possibility. Or he may say, third, he feels indifferent between the two baskets. A and B are indifferent.ไม่แตกต่าง in terms of providing happiness. Okay. If he said, I don't know, bye-bye, we don't want to talk to you. Okay. Okay, I put the word notation and meaning. A is preferred to B. If you don't want to write this long sentence, we have convenient tools. A is preferred to B. This symbol, how to read this, is preferred to. Let's agree on this. It's not a greater sign with some curve. A is preferred to B. Second one would be B is preferred to A. Third, A, zoom. tilde on your keyboard, left hand side corner, top left. Yeah, I saw it. Tilde. A and B are indifferent. That's a notation that equivalent with this statement. Okay, meaning someone is going to feel like this. And this symbol is a if and only if, right? IFF or if and only if ก็ต่อเมื่อ yeah. If and only if. This guy will say he loves to have A more than B. He must feel that U is utility or happiness. Yeah, utility from basket A must be greater than utility derived from basket B. Now you can put the greater than sign. Yeah. Happiness derived from consuming good basket A, it's higher than happiness when he consumes basket B. And second, if he said B is preferred to A, that means he feel that satisfaction from having B it's higher than satisfaction level than having A. And third, happiness derived from two baskets are the same level. Let me remind you, since this is an ordinal approach, care about ranking, not caring about the numbers, don't misunderstand that we are going to compare like, oh, basket B get 100 utils, basket A get 20 utils. No. When I said utility from A greater than utility from A greater than B, level of happiness. Level of happiness. Like, think about this. Like you take elevator to the first floor, second floor, third floor, fourth floor. Higher in level. We don't specify numbers in, yeah? Yeah. Degree of happiness, like a level. So when I use the word, I'm very careful. Satisfaction level. Yeah. Utility level. Think about elevator. Yeah. Like if you consume basket A here, you will be on the fourth floor. But if you get basket B, you'll be on the second floor like this. Okay. Okay. Suppose this guy, he passed this first requirement, he can tell us which one or two or three. Yeah. Now we move to check the second one. This guy must love to have more of the goods rather than less. Yeah. In short, we said this is about more is preferred to less. How many A's you want to have in your transcript? How many A's? Grade A. All. More is preferred to less. In choosing between 20 scoop of ice cream and 10, which one? 20. Okay. So you comply with this as well. More is preferred to less. Yeah. That means more of goods never upset consumer. The more, the better. The more the good, the more amount of the goods, the higher level of satisfaction. Yeah. The level of satisfaction between having, let's say, 3 A's in this semester or 6 A. Wow, very different. Yeah, more is preferred to less. Yeah. Sometimes we said more is better. Keep in mind that when we said more is better, we are talking about something that the more units that you consume give you higher satisfaction level. We are not talking about garbage. We are not talking about pollution here. For those commodities, less is preferred to more. Yeah. The less generate higher satisfaction. We're talking about garbage or grade F. Yeah. Okay. Suppose this guy passed green light. He loved more of the good rather than less. Number 3, this guy must love varieties. Let's check. Present him with the 3 baskets. Yeah. Okay. Let's talk about combinations of food and clothes. Yeah. Okay, this is a food and cloth, not fish coconut. Yeah, that's old story. Tom with coconut and fish. Now it's become food and cloth combination FC. Yeah. Okay. Hey, Mister, I want you to rank your preference over these 3 baskets. To comply with these consumer love varieties, this guy must say that B is preferred to A. A is an extreme basket, contains only one of the 2 goods, only food, no cloth. We call this type of basket extreme basket. C as well, extreme basket, contains only one of the 2 goods, full of clothes, but no food at all. B, mixture basket, varieties, has a positive amount of the 2 commodities. When he said this, we learned already, he loved varieties rather than extreme. B is preferred to A. B also must be preferred to C. We have to check as well. If he says so, yeah, he passed this. He loved varieties. Many consumers obey this or comply with this. When you look at the people at the buffet dinner, very rare to see people just put only one type of the food on the plate. Yeah. They want a mixture of things, generate higher satisfaction than only put only one type on the plate. Okay. Number 3, pass. The last one. His taste must be consistent. คงเส้นคงวาย consistent. We learned mathematics from high school. We used to see this term transitivity. คุณสมบัติการถ่ายทอดเนี่ย transitivity. What is all about this? Transitivity say this. If basket A is preferred to basket B, ask this guy, hey, A and B, which one you love to have? Let's say this guy said, oh, he prefer A over B. And then we ask him next, hey, mister, can you rank B and C? Let's say he said, oh, I would love to have B rather than C. B is chosen over C. If this is the case, then to be transitive. To check whether his preference is transitive, he must say, "Hey, Mr. Third Round, I want you to compare between A and C." He must say, A is rank over C. So when someone say this, you can make the ranking like this. Oh, the first rank is A, the second rank is B, the third rank is choice C. And you may ask, why do we need this? The reason is very simple. We don't want to waste time talking with people like this. Okay, look at this circle. This is called circular preference. Asking this person, hey, A and B, which one you prefer? This guy said, A is preferred to B. How about B and C? B is preferred to C. Last time, how about C and A? This person said, C is preferred to A. Or you can choose, start from B and C and go on. Talking with this type of people all day long, you cannot make this kind of ranking. You will not learn which one is the first rank, second, and third. This is called circular preference. Happens to kids in the kindergarten. Yeah, when you ask to choose candy, ice cream, chocolate. Yeah, sometimes kids get confused, cannot rank. Yeah. Okay. Circular preference. We want to avoid this. That's why we need requirement number 4, preference. We want to avoid circular preference. Okay, now we are on the right track. Let's say this person fulfilled the 4 requirements as summarized in the next page. He can rank. He loves more rather than less. He loves variety. And his preference is consistent. Okay, let's go. Indifferent curve. First of all, definition comes. A curve. Oh, it must be a curve, a line that contains, if you want to have a curve, the basket contained in this curve must generate the same happiness level. If not, it's not indifferent curve. Yeah. In Thai, เส้นความพอใจเท่ากัน same satisfaction level. Okay. Let's have two good eggs, pizza, good wine, Pepsi. Okay. And we only deal with this quadrant, non-negative amount of the goods. Yeah. The worst is 0, 0. It's here. No pizza, no Pepsi. And you can see that in this ocean, it's full of baskets containing the mixture of pizza, Pepsi combination. Yeah. In this ocean. Yeah. Any dot that you spot on, you will see the positive amount of the two goods, or maybe non-negative. Okay. Now, put scale then. Ah, okay. Okay, let's start with a basket A. Oh, which we have 10 pizza and four cans of Pepsi. Okay, pizza, perhaps slight per day. Pepsi, number of cans per day. Basket A, mixture of pizza and Pepsi. 10 units of good X pizza, 4 units of good Y Pepsi. Pizza, when he get hungry. Pepsi, when he feel thirsty. Combination of these two. Okay, we are going to do plot an indifferent curve here from scratch. Textbook will give you right away this curve, yeah, but we are going to build one by ourselves. Okay, read again definition. A curve that contains all baskets, which give the same happiness level to this guy. Okay. What is your name? Nickname? Beam. Okay. Oh, I call you already. I forgot. Who is your good friend? Beam. Blue. Where is Blue? You? Why your good friend stay not close to you then? Or distance doesn't matter? Distance doesn't matter. Okay. I ask you first before we go to talk to him. You want to change your good friend or what? He changed to choose you. Okay, later on, you first. Now, in your refrigerator, you have 10x and 4y's. Yeah. But my job now, I want to plot in different curves which describe your preference over pizza and Pepsi. I want to plot one. And I already know the definition here. If I have a line, the basket in this line must generate the same happiness level to you. Okay, let's taste first. I have this basket for you to compare with A. Yeah. A is a reference point. Yeah. Let's go for this one. Basket L. Which one you prefer, L or A? Mr. Beam. Why L? You comply with these two. I understood. More is preferred to less. The higher amount of pizza or the higher amount of Pepsi or higher amount of both must generate higher level of satisfaction. Utility from L, it's higher than utility from having A. L is preferred to A. Okay. L with 14x and 8y. Wow, a lot more than this, 10,4. Okay, maybe I put it 14, 8. One more test for you. Okay, I pick another point. Point P. Point P. 8,2. Point P. Basket P. Compare with A. Which one you are going to choose? Why A? Because A has more of pizza and more of Pepsi compared to basket P. One more time. How about with this spot then? Compare with this. Which one you choose? This or this? This one. Because yeah, even though the same amount of Pepsi, but this basket has more of good X, prefer over A. Then we reach the one. The first finding is, okay, let's paint. Baskets in this green area, all of them are superior than A. Surely generate higher satisfaction than basket A. So we want to call this region superior region, superior than A. Yeah. And now you can also argue that this area contains all baskets that inferior to A, generate less utility level than A, all of them, including the edge, yeah, the edge. Basket along the edge, everywhere in the area along the edge are inferior to A. So let's call this inferior region. Oh. Okay, now let's draw an A curve then? Okay, we just connect L basket, A basket, and P basket together. We got a curved upward sloping. And if I tell you that this is indifferent curve, what do you say? Oh, you're still painting the color. Mr. Beam, this is your indifferent curve. Are you convinced? This slide. Read the definition and tell me whether you agree or disagree and why. Tell me whether this curve comply with the definition or not. Why?
Containing all the bucket to back like
You are right. Because you prefer L over A, you prefer A over P. L generate higher satisfaction than A generate higher satisfaction than P. How could this line deserve to call indifferent curve? Cannot. Must generate the same level of utility, but we already proved impossible. So conclusion is, if you want to have one indifferent curve, it could not be upward sloping for sure. Cannot. Indifferent curve cannot pass through like a superior region and inferior region. Impossible. We rule out this possibility already. IC cannot be upward sloping. Delete. Now we want to work out on this direction then. The empty space here. How about this direction? Downward sloping. Is this possible? Let's check. Okay. Look carefully now. So who is your good friend? I forgot. What is your name? K-I-M. Kim. You know each other before?
Yes.
Oh, from the same school? Oh, no? Okay. Now, Kim, he has 10 pizza and 4 Pepsi now. You steal pizza from him, one slide. Okay. So, in effect, Mr. Kim moved Mr. Beam to this spot. Let me call spot B. And so I will put here. Remind you that now beam it's moving to point B on the left-hand side of point A, meaning that same level of pizza, Pepsi, but he lost 1 unit of pizza. How do you feel? He steal from you. You feel sad, right? Okay. He want to offer you compensation with this loss. He asks you back, how many Pepsi you want to get compensation for the loss of 1 slice of pizza? How many cans? 3. Why you say that's too much? Why you recommend him that's too much? Three. You want to be compensated 3 cans. Okay. 3 cans. It's your feeling, then I respect your feeling. I will, Mr. Kim will compensate you 3 cans. And make sure that you will stop crying, right? You will stop crying. Because you said that 3 cans will make you stop crying. With this loss, fully compensate enough until you stop crying.
More than 4.
Yeah, I know. Now you have 4, right? You said that if give 3 more, you will stop crying completely. Okay. So move you to here. Plus 3. Now you come to point C. Point C. With how many Pepsi and pizza are? 9 of good X, 7 Y. Okay. 9,7. What we see here, lost 1 of good X. And if he got plus 3 of good Y, he completely stopped crying. Then I can conclude that basket A and basket C are indifferent, generate the same happiness level. Since you completely okay after he compensates you with 3 units of good Y for the loss of 1 slide. Then C must be indifferent to basket A. Now you are at point C, Mr. Beam. He make a second stealing. Move you to point D. A, B, C. Now you arrive at point D. He steal another one. How many cans you want now to compensate with this loss? Still 3. First stealing, you request 3 cans of Pepsi. Second stealing, how many?
Fair.
To be fair, okay. You make my story difficult.
5 more. 3.
5?
5 more.
I have to create a special diagram for you. 5 more, okay? Okay, 5. 1, 2, 3, 4, 5. Okay. Plus 5. Now you come to basket E with 8 units of good X pizza and 12 units of Pepsi. And again, you stop crying already. That means basket E must generate the same satisfaction with basket C. So I write again. A, C, E are all indifferent. All of them generate same level of satisfaction. Once you get fully compensated with another good for the loss and you feel completely okay, that means you are indifferent between E and C and A. Okay. Now I connect. Let's connect E, C, and A. And this morning, I did three times stealing, but according to Mr. Beam numbers, I have no scale anymore to go on. Yeah. But that's okay to discuss about this. First unit loss, the consumer requests 3Y to compensate and stop crying. Second time loss, the consumer requests 5 units of good Y to compensate with the second loss. That means if this is the case, he valued the loss of first pizza and second pizza differently. It hurts him more for the second loss. That's why he requests higher amount of good wine to compensate. Make sense? When number of pizza start to get diminished, he feel more sad with this. Yeah. That's why he requests for more Pepsi all the time. If you complete this thought experiment, yeah, you got the IC. Here I start with point A. You can also imagine that if I start with somewhere here, yeah, IC would look like this. Yeah. Downward sloping shape. Yeah, like this. In different curves. Our thought experiment start from point A. You can start from any other point. Let's say if you choose point L, you can create one too. This point, yeah, whatever point. With this thought experiment, you can construct an IC. There are millions of the curves on this space, consumption space. Yeah. Okay. All right. Now we are able to plot in different curves by ourselves. Here, next is properties of indifferent curve. Indifferent curves are downward sloping. Okay. Why? Okay, let's check. Good X pizza. Goodbye Pepsi. Let's look at an indifferent curve. Here, We have 4 baskets A, B, C, D on this indifferent curve. Surely, if we use our simple on indifferent curve, I see 1. Basket A, B, C, D are on the same curve. That means A, B, C, D are indifferent. That means utility from A equal to utility from B, utility from C, and utility from D. All baskets give the same level of satisfaction. That's what we can argue. Now we want to focus on why the curve is downward sloping. Why downward sloping? Check this. Start with basket A. So I just make up the numbers. Look, from basket A, with 1 pizza, 12 Pepsi, 1,12. Basket B, 2 pizza, 9 Pepsi. Basket C, 9,3. Basket D, 10,2.5. Okay, start with A. What we should notice first, look at his basket. Wow, a lot of Pepsi, very few pizza, only 1 slide. He must be hungry but not thirsty here. Yeah, hungry but not thirsty. And now we want to offer, yes. Oh, sorry. Thank you. Hungry but not thirsty. He is not thirsty. He has a lot of Pepsi. He has a lot of Pepsi. He's okay if he's thirsty. He just open refrigerator and drink. But now he want to have more. Right now he is hungry but not thirsty. Look at his endowment. Yeah, ทรัพยากร endowment. He has more of good Y, but less of good X. Okay, now this guy want to trade between X and Y. Okay, we offer him, hey, mister, I know that you are hungry. If I give you one pizza, how many Pepsi you want to exchange with me? This guy said, look, this guy said, I give you 3. Please give me one pizza. He willing to trade 3 cans of Pepsi in exchange for one more slice of pizza. Right now, he is quite hungry. Yeah. But when he further eat pizza, we ask him again. If at point C, we ask the same question to him, hey, mister, if I will, how many Pepsi you willing to trade for one more slice of pizza? To get one more slice of pizza from 9 to 10? He said, if he have to, he willing to give up only 0.5. Here. Minus 0.5. Which makes sense. When consumer has a lot of good Y, little of good X, he willing to trade the things that he has in abundance, a large amount, with something that he still desperately needed, pizza. But once he start to get full, we ask him the same question. The willingness to trade Y for X becomes smaller, only 0.5. That's why slope of indifferent curve, it's not only downward sloping, it's getting flatter, and flatter, reflect this rate of exchange here. Okay. Number of Pepsi he want to sacrifice change depends on the level of his hunger. Okay. All right. So then let's talk about this rate then. If we do delta Y over delta X here, what do you get then? Let's do it. He willing to sacrifice 3 units of good Y for 1 unit of good X. So we got minus 3 here. And we want to compute over C and D as well. Delta Y over delta X. At this moment, he almost full. We asked him his willingness to trade Y for X. He said, oh, if I have to, I want to trade only, sacrifice only 0.5 units of good Y for 1 unit of good X, minus 0.5. Consider only magnitudes. Ignore the sign. You can see that the magnitude is reducing. You can imagine this is a slope of the curve actually. Slope is getting flatter. The magnitudes get smaller. Move from high number to low number. Yeah. Willingness to trade. And you understand the contents of this already. Now I put elegant words to this. This rate has a name. It's called marginal rate of substitution. Marginal rate of substitution, MRS, between the two goods, MRS XY. Okay. Just the name for this ratio. Change in Y over change in X reflect how this guy willing to trade one good, here good Y, for another good X. And this rate varies all the time. He will not stick with the same answer. The number change from a big number to become smaller. Depends on amount of goods that he has in his basket. Depends on whether he's hungry or not. Yeah. All right, makes sense. Yeah. Okay. And add on. So this rate is falling. Consider only the magnitude. Yeah. Consider only magnitude. Amount of Pepsi he willing to give up to get a slice of pizza change all the time. Depends on level of his hunger. That's why MRS is falling. Somewhere here is 3. Somewhere here is just very small, 0.5. Okay. We consider only magnitudes, not the size. Just trade off between the two goods. You know for sure it's minus because it's about trade. Reduce one thing to get another thing. Reduce one thing to get another thing. Yeah. Okay. Clear? If we can look at this picture from top to the bottom, shall we try another way to get another interpretation? We can do both, yeah. Student at BE, they quite frustrated about this, yeah. MRS thing, yeah. I'm not sure whether it will happen to you as well. But I will tell you that you can look at this both way, yeah. Depends on the story that you want to make, yeah. It's not only required that you want to travel only from the top to the bottom. Let's travel from backward. What kind of interpretation that we can have here? Here, let me remind you, when we travel from top to the bottom, the story about trading Pepsi for pizza. Trading Pepsi for pizza. Then let's travel up. D to C. D to C. You have to swap everything, yeah? Swap, yeah. Green to red, red to green. D to C is about this. Oh, D to C is about this question. Hey, if I steal one pizza from you, how many Pepsi you want to get compensated? This guy said, give me a half can. Again, the question would be, if we take away X from him, how many Y he want to get compensated to feel completely okay? Go back to the same indifferent curve. Travel, loss and gain, loss and gain. Look, she said, give me a half can, I will be completely okay. Get back to the same level of utility. Point C is on the same curve, like point D. One more time. At point B, when the number of pizza almost running out of, yeah, only 2 slices left, and you still want to take away from him, you could expect for sure that, oh, this is where you are. This slide is quite meaningful to him compared to this slide when when he has 10 and we take away 1, become 9. It's different feeling when he has so little and we still take away from him. We take away one X from him. Now he said, to compensate with this lot, he requests for +3 Pepsi. Get back to the same indifferent curve. Point A is on the same curve. Yeah, that's an interpretation. When you look from downwards to upward, yeah, willingness to trade again. Okay, all right. Wow, the property number 1 spend a lot of time. Yeah. Number 2, Okay, maybe I say I see two. Okay, when we wrote IC1 and IC2, it may give you the wrong impression that in between these two noodles, nothing here, but that's wrong. In between these two spaghetti noodles, there are thousands of indifferent curves lying next to each other. It's like you have a paintbrush. You brush it on, and you just select some to show, actually. So what I want to do is this. I make a brush. Like this. Here, family of indifferent curves, thousands. We just select two to show. Yeah. Actually, there are so many. Yeah, line up like this. Yeah, next to each other, like this. We call a family of indifferent curve. We call indifferent map. Okay. Just right next from IC1, there is a one noodle here next to IC1, and go on and go on and go on. So a family of thousand indifferent curve we call indifferent map แผนที่เส้นความพอใจเท่ากันแผนที่อ่ะ map okay you know that's why it's quite logical to do like this. If this guy first he stay on this IC1, if you give him more of good X, more of good Y, he will travel to the better one like this. Oh, like this. Makes sense. Every time when we give this guy more of pizza or more of Pepsi, his satisfaction level jump to the higher IC, higher and higher satisfaction level all the time. That's why there is no gap between IC at all. Yeah. But let me, I just zoom in. Yeah, zoom in. Okay. That's why moving toward northeast direction like this, it's about give him more of pizza, more of Pepsi, or more of both will increase his utility. It's like a vector. Yeah. And anywhere you can start like this, you will see that, oh, you make him happier like this all the time. Yeah. When he has a little bit more of this, a little bit more of that, or a little bit more of both, always helped to increase satisfaction level, jump to the higher indifferent curve, higher satisfaction level. Yeah. Then lesson learned here, the higher the indifferent curve to the northeast give more happiness than the lower one. Yeah. The higher the IC towards NE, northeast direction, the higher the satisfaction level. Okay. Third, 1, 2. Okay, number 2 finish. Number 3 actually finish as well here. The higher the IC toward northeast, the higher utility level. 2 more here. This one I already discussed. Okay. Number 4. I will do number 4 and you do number 5 at home. Yeah. Yeah. Why? It's the same logic. Yeah. It said, if you pick, listen this part carefully. Yeah. Here, property number 4 said, indifferent curve do not cross. I mean, this if this is an indifferent curve for Mr. Bean over Pizza and Pepsi, you have 1,000 of IC here. They lie next to each other, no crossing at all. Yeah. Okay. And now, if you don't believe in this, you want to challenge this statement. I don't believe it. What happens? What's wrong if the 2 different curves cross? If from Mr. Beam's indifferent map, what's wrong with crossing IC? Let's check then. We are going to challenge this statement. Yeah. We call this as proof by contradiction. What is all about proof by contradiction? You challenge this statement, let them cross and see what went wrong. Yeah. If something goes wrong, you have to admit that this statement is right. Yeah. But if nothing happens, then you should say that this statement is bullshit. Yeah. Okay. Let them cross and see what went wrong. Yeah, if you agree with this idea, this proof, if something wrong emerge, then we should agree with this statement. Okay, let's check. We have red and blue IC come from the same map. Yeah. We start with basket B-boy. Yeah. Basket B. Yeah. Like you, Mr. Beam, basket B. contains X1, Y1 pizza and Pepsi? We also have basket A. Let's call X2 and Y2. And basket C in this, let's call X3 and Y3. Okay. Okay, let's start from the blue IC. Then let's see on IC1, what do we see? What do you see on the blue IC? What basket? B and C, right? B and C are on the blue IC. Then, since basket B and C are on the same different curve, it must generate the same level of satisfaction. That's conclusion. Since B and C are on the same indifferent curve, conclusion, then we conclude B and C must be indifferent. Full stop. Oh, that's right. And now we look at the red one. On the red IC2, we saw basket A and B are on the same curve. Since the two baskets stay on the same indifferent curve, it must be that basket A and B must make this guy equally happy, same satisfaction level. So since A and B, I call B and A are on the same IC, then it must be that B and A must generate the same happiness level too. Okay. By transitivity, B and C are indifferent. B and A also indifferent. So use B as a connection. Then we can argue that basket A and C must be indifferent by transitivity property. A and C generate the same level of happiness. We got it. Okay. This is a statement that we got here. Another person come. Say that, wait a minute. Look at the amount of pizza and Pepsi in basket A and C. He complained this. Look, basket C has more pizza and Pepsi compared to basket A. Impossible. Since C has more of X and Y, then buy more is preferred to less. It must be that C basket that has more pizza and Pepsi must be preferred than to basket A. When we allow for crossing IC, it generates these two statements. A equally preferred to C. Another one said C is preferred to A. That's the contradiction generated from this picture. Why we say this is contradiction? Because either this or this, only one is true. This and this cannot be true at the same time. This is called contradiction that found. Why we found this? Because we let IC cross. We found this contradicting statements. What is the solution then? If you want to avoid contradiction like this, don't let IC cross. Okay. Salute. I believe you now that IC cannot cross. By this proof, it generates something smelly wrong like this. Okay, landing point. By allowing IC, allowing crossing IC, it generates a contradiction. Why we call contradiction? Since two statements cannot be true at the same time. It's quite strange. Either C and A or C is preferred to A is true. Cannot be true at the same time. Yeah. Yeah. Then to avoid such contradiction, don't allow for crossing IC. End of the proof. Job done. Okay. And that's it for today.